Hey everyone, welcome back to our daily LeetCode challenge series. So today is day 99 and today we're going to solve LeetCode problem 19. Remove nth node from the end of the list. Okay, so this is a medium level problem. So let's see the problem first. Okay, so we have given the head of linked list. Remove the nth node from the end of the list and return its head. Okay, so we have given this picture. So here we can see we have the linked list is 1, 2, 3, 4, 5, and the node that we have to delete from back, the second node, right? So this is the 4. So after removing the 4, we will have 1, 2, 3, and 5. So basically head we have to return after deleting the nth node from the end of the linked list, right? Fine. So in this example, we can see the second has been removed. So 1, 2, 3, 5 is the our output linked list, right? Similar example 2, we have only one node, right? And we have to delete the first element from the last. So there is none other than one element, right? So if we delete, our set list is null, or we can say empty, right? Similar example 3, we have 1 and 2 as a single linked list, and we have to delete the first node from the last. So basically 2 will be get deleted and we will return 1, right? So in constraint part, we have given the number of nodes in the list is SZ. SZ, like we can say size, and size can be varies from 1 to 30. So maximum 30 node we can have. Okay, and if we talk about the values, so value can be range from 0 to 100 of the node value, right? And can be less than and size and greater than 1. Fine. Follow, could you do this in one pass? Okay, so basically they are asking to do solve this problem in the one pass. Okay, so now what we'll do in this case, like as we have done multiple problems using slow and faster approach, right, in one go. So similar like approach we are going to use here, right? The thing is, we have to remove the nth node. So in order to get the last nth node from the end, what we'll have to, we have to create one two pointer, right? And we will first make a difference among these two pointer, and then we'll start our two pointer approach of slow and fast in this case. Okay, so whenever we reach the faster pointer at the null, that means the gap that we have taken currently will be the nth node from the end, right? Then using that slower pointer, we are going to delete the next node from that. So same logic that is going to happen. Okay, so let's come to the solution part. So we have similar definition of the list node, val and next and other like a structure and all, right? So this is now used. We will remove from there one. So fine. So in order to solve this problem, what I'll do, I'll first create some temp node. So temp node will create using a list node, let's say temp, okay, which will be a list node. And by default, I'm just giving the value of this temp node as -1. So we will have the better track, right? And now what I'll do, I'll assign this to our next pointer to our head that we have currently getting in the response, in our method signature, right? Now, we will have to create two pointer as I told, like slow pointer and fast pointer. So let's say list node slow equals to, which is pointing to our temp node, right? Similar way, we'll create our fast pointer as well, which is going to point our temp node, right? Which is the starting of the temp node, right? We are not going to modify our original linked list, right? That's why I created a temp node, and on top of that we will work. So now we have to find the gap between the slow pointer and a fast pointer. So whenever the fast pointer is the null, that means the difference among the slow and fast will be the n value, right? So let's take a variable gap. By default, I'm giving 0 because currently both pointer is at the same place, so there is no difference. Okay, now we will have to make difference. So what we'll do, we'll do gap should be less than the n value we are getting currently, right? Which is the gap we needed. So what we'll do, we'll move our fast pointer first, fast dot next. So after increasing one by one, we are going to increase our gap as well. So basically we are increasing one element at a time. So let's say first point is currently at 1, then we'll go to 2, and then we'll go to 3, 4, so vice versa. So whenever we got that difference among these two, so we will stop there. So now once we reach the and difference, so let's say two difference we have got from slower node and faster node. Now what we'll do here, we'll again check if fast dot next, if not equals to null, then we will start iterating both the pointers. Now slower pointer and faster pointer, both we are carry forwarding. So we'll make slow dot next. Okay, similar fast equivalent fast dot next. Okay, so now we are moving both pointer at a time till when the first pointer not reach to the last one. And once it is reaching, that means we have reached a difference. So slow pointer will be exactly at the end node from the last, right? So now once we reach that exact path, what we're going to do? We are just going to delete the node slow dot next will be slow dot, sorry my bad, next dot next. Okay, so we are just removing that next node of the slower. That basically the task we have to do in the program statement, right? And at last, what we'll do, we'll simply return our temp dot next, because temp we have created -1, so we have to return the head, right? So that's why we are returning the head using temp dot next, right? Hope it will work. Let's submit and see. Okay, so all three test cases got accepted and we're getting expected output. Now submit and see other test cases as well. Okay, cool. So all 208 test cases got passed and beats 100%. So our service is anyways quite optimal. Okay, no doubt on that. So yeah, if we talk about the time complexity here, so anyways, we are iterating over every element right here. So time complexity is going to be big of n. And if we talk about space complexity, so we are using constant space, right, in order to store variable and making the temp node, right? So it is anyways big of 1, right? If you know any other approach than slow or faster pointer approach, then you can comment it out, right? So that's all for today. Let's see you next video. Bye.